Hello and welcome to the third in this series of 5 webinars presented by Informs to help people prepare for the CAP exam and provide more information on the topics included in the CAP program, especially the examination portion. This presentation will be available after today, just like the first 2 webinars are currently available on this site for listening and viewing. If you have questions during the presentation, feel free to post them. We'll answer as many as we can, and after the presentation, we will answer the rest if you include the address to which we can direct our response. And of course, if you think of a question later, send it to me at certification@informs.org. Our presenter today is Dr. Robert Bordley, who earned his PhD in OR, and he has an MBA in finance from the University of Cal Berkeley. Bob is also a CAP. And, listen to this, he is an expert systems engineering professional, a project management professional, a fellow of Informs, the American Statistical Association, and the Society of Decision Professionals. Bob has written 85 published articles. They were published in journals of statistics and operations research. He's been awarded Best Publication from the Decision Analysis Society. And while he was at General Motors, he earned the Chairman's Award, the President's Council Award, the Award of Excellence, the UAW GM Quality Award, and Outstanding Engineering Award. Bob has been a program director of the National Science Foundation, and of course at GM he was the technical director and a technical fellow. Currently he works at Booz Allen Hamilton and teaches night courses in both decision analysis and systems engineering at the University of Michigan. We were just talking, and he's going to be using a new blended approach to this sort of course in the near future. Bob helped write the CAP study guide and especially the data domain. I understand that occasionally he sleeps. And now I'll turn it over to you, Bob, and you can present the CAP refresher on domain 3 data.
Okay. Well, thank you.
You're welcome.
All right. Let me start off by just talking about, generically about what data science is. It's required the extraction of timely, actionable information from diverse data sources to derive data products. And the words extraction, timely, actionable, and diverse are all very, very important. It also creates an environment where models are constantly tested, dated, and improved until better models are followed. That's one of the ways in which data science, differs from potentially more traditional understandings of databases. And I'm going to talk a bit more about, each of those key terms and how they play into the, CAP exam. And let me move into the CAP exam. If you've taken any of the previous courses, you've seen this outline before of the various domains of the exam: business problem framing, analytics problem framing, data, methodology, model building, deployment, and lifecycle maintenance. And I'm focusing on data. The data portion of the exam is about, a quarter. As you can see, it actually has potentially more weight than any of the other sections, and that's because there's an awful lot of material included under data. That can make it a little bit overwhelming for people to prepare for, and I'll do my best to try to help you through it. All right, our task at the high level, we want to identify and prioritize data needs and resources. And the key thing, and we're going to talk about that, is that Not all data are created equal. We're not simply about trying to come up with convenient ways to archive as much trivia as we possibly can. This is not about collecting trivia. Acquire data. And again, not all data sources are equally credible. If you go on the internet, you see an awful lot of information there. Wikipedia isn't bad, but in some cases, it has some questionable information in it. And some data sources are just downright, worthless. Harmonize, rescale, clean, and share data. Not all data comes in a form and quality where it can be easily used. In fact, very rarely does data come in that form. If you do get data that comes in a nice form, it's probably been used for another purpose, and unless your purpose happens to be the same, it's probably not quite all the data you need. So typically you're going to have to do some work here. Identify relationships in data. When people originally talked about the start of data mining, they would, the famous example was people finding a connection between the purchase of diapers and beers. That may be a relationship, but again, we're looking for relationships that are meaningful and that are actionable, that, again, we can do something about. Again, we're not here to collect trivial patterns. We are here to collect patterns that matter and that are actionable. Document and report findings. As an analytics person, it gets easy for me to get lost in the numbers, and and everything makes sense to me and is very, very clear. But then when you communicate to other people, you often found that you need to get outside of your reference frame. People simply can't understand what you're talking about. Complicated is not better. I mean, it's tempting to get out complicated because you want to show all the different subtleties, but simpler is easier. A simpler, okay solution can be better than a complicated, optimal solution, because simpler is easier to prototype. It's easier for people to understand. It's easy for them to communicate and justify to their clients. It's easy to implement, and it's easy to verify. So wherever possible, we want to be able to press the easy button. And finally, refine the business and analytic problem statements. At least I've found that where data is especially valuable is when it tells us that we're looking at everything the wrong way. When it tells us that we're asking the wrong questions and have to reframe our problem statement, have to look at it differently. That's really where data can be very, very helpful. And when you can really start getting the mega billion kinds of improvements. I'm going to go into task 1. You see K2 through K13 listed here. There are 17 knowledge elements that are critical, and we've labeled them K1 to K17. And on task 1, you can see the different knowledge elements that are applying here. I'm going to talk about some, but not all of these, because there's too much detail. So in task 1, identify and prioritize data needs and resources. Data comes in a lot of different forms. Sometimes you have textual statements. Sometimes you have images. Sometimes you have numerical. I mean, a lot of us are most comfortable with numerical, or at least that's how I grew up with, was numerical and number information. But a lot of the information out there doesn't fall into that realm. And even if you have numerical data, there can be a lot of different kinds of variation. Some numerical data can be precise, like there's 365 days in a year. Some data is noisy. For example, there might be variability in the number of parts produced in a manufacturing process. when you're talking about that kind of variability, at least you've got some understanding about what the variability is. That it can be described by some kind of normal distribution. Or at least you have to use control charts to track when it's moving away to a different distribution. So at least you can able to hang your head on some kind of well-defined distribution people talk about. And in other cases, we're talking about things where the data is a lot softer. For example, where the data reflect individual judgments. It's nice to think that the only kind of data we need to work with is quantitative or hard data. And a lot of times you have that, but typically to really get to solution, you have to bring in this other kind of data. Some of it's locked in people's heads. It reflects their expertise. It reflects, gut instincts, judgment calls, and the like. A theory about how to deal with those kind of soft numbers has been developed, based on the idea of economic rationality. And there are different kinds of approaches. Some approaches ask people to directly estimate, the numbers, like how important is a quantity. Again, when you talk about trying to assess that, you have to make sure things are well defined. For example, when you talk about importance, typically asking the question of whether something's important or not is a bit meaningless because you're really looking at range of variation. Diamonds are potentially more valuable than water if you're in a society where water is plentiful. If you're in the desert and you have no water and you have no diamonds, water is a lot more important than diamonds. So again, you need to provide enough context when you're trying to do these assessments. That's one of the challenges in dealing with soft data. You need to do an awful lot of work to precisely define them so that your data is, in some sense, verifiable, which is, a key property if you're going to do any kind of analytics and want to put any kind of numbers into a model. In addition to direct assessment, numbers can be indirectly assessed by observing behavior. Economists often do this by, looking at field data, what people often do. But it can also be done with, conjoint experiments, where essentially you ask people to, to make different choices and you observe data from those choices. So again, there's a lot of different methods for trying to assess or convert soft data into hard data. Whatever you do, whatever kind of information is, whether you're talking about the number of days in a year, whether you're talking about, the variation in the size of parts coming out of production process, or whether you're talking about soft data, you need to have some kind of indicator of, the range of variation in this data, what your confidence is in the data. Whether or not you're talking about a number that's right, that you think is on target, or whether or not you're giving a general, rough order of magnitude assessment. All these numbers can be used and are used, but you need to specify, the confidence level. And that will allow you to quantify your data in a form that can be used by the modeler, which is what we're interested in doing. Now, I've used the term data and thrown it out a lot. What is data? The best definition or simplest definition of data I've heard is that data are observations that reduce our uncertainty about the variables of interest in our analysis. And that definition raises a number of questions, like, what do we already know about this variable? If we're talking about a variable where we know an awful lot about, like the number of days in a year, there's not much point in gathering much more information about it. If we're talking about something that is less well known, maybe there is some value. So we asked the second question, if we go out and gather new data, how much will it reduce our uncertainty? If you flip a coin 5 times, the chance of heads is 50%. Trying to flip the coin more is useless because the chance of heads is 50%. Flipping the coin, 15, 300, 1,000 times isn't going to give you any more information about the chance of the next coin flip coming up heads. On the other hand, if you're talking about whether it will rain tomorrow, You might only have a gut instinct that says there's a 10% chance of rain. And when I say gut instinct, if I told you that, say that it rained 3 times in the past, if I gave you that information, maybe your estimate would change to 70%. Your willingness to change your number from 10% to 70% based on 3 observations tells me you're not very confident about your assessment. Whereas with a coin flip, if I told you that I flipped the coin 3 times in the past and I got heads all 3 times, you would still think that the chance of heads is 50%. You would just say that my flipping the coin and getting 3 heads was just straight luck. So that's the second question. How much will new data reduce our uncertainty? And third, if it does change our beliefs, our uncertainty, will this change our decision? Will the decision made if the chance of rain is 70% be any different from the decision made if the chance of rain is 10%? If you're making a decision about whether or not to have the picnic outside or whether or not to carry an umbrella, it might well change your decision. On the other hand, if you're making a decision about the kind of tank the Army should build, then probably that information is totally irrelevant, and there's no point in gathering the decision. In that case, the information isn't actionable. The next test is acquiring data, and you see again the different key knowledge elements under this topic. One of the key knowledge elements is about interviewing, questioning techniques. That was the second knowledge element. And there's a lot of ways that you can go about questioning. You can have a one-on-one interview, and generally when you're dealing with an important source, you have one-on-one interviews. Or you can have a small focus group, small group of individuals together and, potentially raise a topic and have them as a group try to answer those questions. Or finally, you can send out surveys. There's a lot of different combinations people can use. In all of these techniques, there are some important guidelines. Don't ask more questions than are necessary. I've been accustomed to marketing surveys where, everyone wants to add their questions to the survey to get information about, buyers of our product. And the survey could easily run to 10 or 12 pages. And what happens is, if you send the surveys out, people will get these surveys and, they might answer the first 2 or 3 pages. You'll have a few people that will fill out all the pages. There's actually some interesting statistics about the people who tend to fill out the entire survey. They tend to be people who are retired with a strong sense of conscientiousness. Actually, I think, nuns are very, very good at giving out surveys. A lot of other people are very poor. I mean, typically it helps if you give them a small inducement like $1 or 2. If you send some people some money, oftentimes they'll feel like they have an obligation to, do something in response, and they will fill out the survey. But even then, when you get to a long survey, when they get to page 3 or 4 or 5 of this endless survey, they'll start just giving in some pat answers. So you have to be very careful about framing your questions. You want to make sure that you get the questions that are of most valuable to you answered up front, and the questions that are less important, answered near the end, because you may not get to them, or you may see the interviewer's eyes glaze over, if you are interviewing them in person. When you ask questions, it's important to do your homework. You don't want to ask people questions which, they don't have the answer to know. If you're going into a meeting and you want to get questions about, for example, the quality or the characteristics of an engine, and the people in that meeting include people who are experts in engines, but people who are experts in transmissions, people who are experts in appearance, people who are experts in various other kinds of things, then it's only polite to excuse those people to our transmission experts, our body experts, and the like, because you're wasting their time. There's no point in having them sit through and listen to other people give answers to questions that they don't have answers to. Even on one-on-one surveys, if you ask a person a question that they really don't have an answer to, the worst possible thing is the person might give you an answer anyway. I mean, you might get an answer that's a bad answer. They might give you their, off-the-cuff kind of assessment. And so you always want to answer. Before you ask someone a question, you always want to say, is this person likely to have an answer to this question? Is this person likely to provide, good information? And if they're not, then you want to be very strategic. Your respondents have to be treated with respect. They volunteered to provide you with time. That's a valuable resource, and you don't want to, abuse that. And it is easy to do that. You want to avoid forcing people to go through a lot of mental gymnastics. So you want them to use terms and units of measurement that they're familiar with. I mean, we may love the meter system, but if you're talking to people, for example, in naval architecture, oftentimes they like to think in terms of knots and feet and the like. Then ask questions in terms of feet. If you're in a setting where you ask someone a question and then they break it down into pieces and start doing calculations, reframe your questions. You don't want to use your respondents to do simple arithmetic, summing and multiplying that you can do. You want to ask them questions that, and then have you do the processing. It's important to ask clear questions and provide context. Typically, it's important to provide some introduction about how you plan to use that information, and you want to use pictures and visuals where appropriate. One of the big problems that people find who use surveys and even interviews is sometimes the question you think a subject is answering is not the question which the subject believes they are answering. Sometimes they interpret the question very differently. If you're doing survey analysis, you have a very, very difficult situation because you don't have much way of knowing, who's answering which question, the right question, what question they're asking. So again, there are a lot of pitfalls to, doing questions. There's an art and a science to it, to collecting information from individuals. Just as there's an art and science to any kind of, data collection. Task 2, acquire data. And again, you see a set of different knowledge elements. Negotiation techniques, data rules, architecture, data extraction technologies. A basic thing that's important to keep in mind is that there are different kinds of data, nominal, ordinal, integral, and ratio. You probably all know that, but it is basic knowledge that if you don't have, you should look it up. And again, it's very important to document the source of the data. Typically, when a model is run, 80% of the data provided ends up not mattering to the decision being made. There will a few bits of data elements, a few bits of information that will matter. And at that point, it becomes extremely important to go back and determine whether or not that data element is reliable. I mean, is your decision being swayed because one or two people had a strong opinion? Or is it being swayed because you have a data that's based on a data source that is potentially suspect? You need to investigate, because if the decision is swinging on 2 or 3 data elements, you want your client, you want your decision maker to feel confident that, rock solid confident that when people ask him, why are you making the decision, that he can point back and justify it. Otherwise, you'll embarrass your client, and embarrassing your client is a very, very, very bad thing to do. All right, acquiring data. We want to acquire data which is going to improve the quality of our analysis the most. I made reference to a decision tree, but potentially there's a simpler, although equally rigorous way of thinking about it. You identify the decision that would be made if you did not collect the data. What would the client do right now if there was no further information based on their best guesses? You can now say, what's the risk of not collecting the data? To answer that question, imagine, hypothetically, that you were off to collect this data. Imagine all the possible answers. So maybe you go out and collect the data, and you have one set of data that says, everything is as you expected. But another possible outcome is you get data that's, a lot more extreme than you expected, that's worse than you expected. And a third possibility is you go and collect data, and the data ends up saying that things are a lot better than you expected. Now consider each of these findings. The findings were things where the data says things are worse than expected. Would it lead you to a different decision? And if so, how much better off would your client be, assuming this worst case, if they made this different decision versus what they would have otherwise? Likewise, another possible finding is that things are as you expected. And the third finding is that things are a lot better than you expected. Again, would you make a different decision? And what would be the value of making this different decision if you had that positive outcome? So far, what you've done is you've just done a mental experiment. You've thought through the possible outcomes that might happen from collecting the data. And in this case, we said there was worse than expected, better than expected, or as expected. And you've looked at and saying, if it's worse than expected, and I didn't collect this data, so I just stuck with my original decision, what would be the cost to me? And if it's better than expected, but I didn't collect this data, what would be the cost to me? If it's worse than expected, then potentially I, might have taken more preventative measures. So potentially not collecting the data exposes me to some downside risks. If it's better than expected, then potentially I've taken some preventative measures that weren't necessary, and so I've lost some money. And so now I know, what potential I could lose if the data comes out in these unexpected ways. I now have to ask the question in my mental exercise, what's the chance of my getting a result different than what I expected? What's the chance of my getting a result that's worse than I expected? What's the chance of my getting a result that's better than expected? And so now I've got a consequence. What's the downside risk if I don't collect the data? What's the chance of this downside risk occurring, namely surprising results? And that gives me an estimate of the value of information. What is the risk if I don't collect the data? One of the important truths is that if you'll make the same decision regardless of what the data says, you shouldn't be gathering the data. You're sort of wasting time and expenditure. Now, in some cases, your client may have to defend his decisions to others, to his manager and his executives. And so, they may want to gather information to defend against those kinds of outcomes. But in general, you need to ask yourself, what information is it important to collect? I mean, there might be things that you really know very little about, but getting more clarity on that isn't going to help you. I mean, maybe you're not quite sure about, what the future sales of a vehicle will be. But you'll find that, and if you do all these market studies, maybe it'll reduce your uncertainty by 50%, which is a lot. But maybe that 50% reduction isn't going to change what you're going to do about launching a car program. Then in that case, maybe it's not worth collecting the data. So that all relates to prioritizing your data. Go after the data that's going to inform the decision the most. Go after the data that, that opposes the most risk if you don't collect the data. Because ultimately this is all about guiding and shaping decisions. It's not about creating a database with a lot of elements in it, because what's going to happen, especially in the world today we have, is the database is going to become obsolete. And if there's not strong actionable value in the database, people aren't going to maintain the data to keep it up to date. So it's important that it be actionable so that it continues to be maintained and continue to be used. Next tack is harmonizing, rescaling, cleaning, and sharing the data. And there's an awful lot of methods that come under this kind of heading. Data cleaning is important to ensure relevance. Oftentimes you'll have valid and invalid responses. Sometimes there are key punch errors. Someone just put in the wrong value, or somehow someone managed to put in an illegal response. Ideally, for example, if you're sending out a spreadsheet or some other kind of device for people to fill information in, you can set it up so that it's difficult to put in an invalid response, so that only legal responses are valid. And that would be helpful if you're sending out a spreadsheet. Look for inconsistent data. That's often an indication that again, you're getting low quality data, there's mistakes. Identify suspicious responses. One of the things that happens a lot in surveys is you'll see cases where you ask a person, do you strongly agree with various statements? And you'll suddenly notice that the individual will check either strongly agree with everything, or strongly disagree with everything, or just right down the middle. You'll see these kind of patterns. And that's a good sign that maybe the subject is really feeling very good, or maybe they're just getting tired and they're just giving all ones or all threes or all fives because they just want to get through the tasks. They just want to get this work over with. Look for suspicious distribution of factors or suspicious relationships between fields, physical relationships that don't make sense. You're always asking, does the data make sense? One of the things that I've been burnt by a few times, not burnt, actually embarrassed, is we had data on a portfolio of projects in this Excel spreadsheet, and someone was managing it. And I would meet with people, they'd ask me questions, I'd go to the spreadsheet, and I'd get some stupid results coming out because it turned out the Excel spreadsheet had got corrupted. The standard things, someone puts in an extra column or an extra row, or fields get redefined. Spreadsheets and databases get corrupted, and you end up getting stupid things, and people will point that out to you, and that can be embarrassing. It reduces the credibility of the database. People stop trusting the database because they don't know whether or not there's going to be an Excel error that corrupts all the information in it. That undermines the decision maker, and again, not a good situation. So does the data make sense? You constantly have to sense check to see whether it's, to see when things come up. Because if there's anything wrong with your data, there's a good chance that there's going to be an application or client where that error comes up. And you've got your own credibility to worry about. Why is data cleaning needed? I talked about the symptom that individuals filling out long surveys tend to skip the last page. Sometimes individuals simply refuse to fill out certain kinds of information. Like in surveys, it's very common to ask people their incomes, and sometimes people refuse on principle to put in income. Sometimes they decide that they're sufficiently irritated that they'll put in $1 million or $0 or some other kind of response. It's like when people put down their name as Ronald Reagan. So you need to do data cleaning because sometimes people feel that you're asking a question that you don't have a right to answer, or they get irritated by it. Certain kinds of individuals are prone to avoid filling out survey, and this can systematically bias the results. There was the famous embarrassment of Dewey defeats Truman. A lot of you are probably too young to hear that story, but the newspapers were all reporting, based on their polls, that the Republican Dewey would easily defeat the Democrat Harry Truman. And how these polls were done, is they tended to, call people and ask them their feeling. And at the time, not everyone, had phone numbers. And so they were systematically not calling a lot of the people who actually turned out to vote for Truman. So Truman won the election and the polls were off. Clearly political polls are better these days, as we now know from recent elections. But again, it's a famous example of this kind of non-responded and bias. Data entry errors, very, very common. Sometimes different codings can be used for different states. When I worked at General Motors in the car industry, we make a lot of products, different kinds of Chevy cars, and it turned out there are about 4 or 5 different kinds of ways you could refer to the Chevy vehicle, and different people in the company, different database developers, would use those different kinds of names. Or some of them would use a very, very specific name for the Chevrolet, including, that it was a Chevy 2-door with its color, whatever. Some would move more generic names. Some would put all Chevrolet small cars into the same bin. Some would put all GM small cars in the same bin. They would categorize their records in many, many different ways. And it was a struggle trying to piece these out and trying to create a single database that would systematically, have different records all grouped at the same level of granularity. So that is an issue and very, very hard to struggle with, especially when you have people who are creating databases for different purposes. Blending those databases together, is hard. And, in some cases, maybe not the worth the effort. And again, are individuals blindly filling in the same answer for several unrelated questions? Is it like, just trying to get through it? So there's a lot of reasons why data cleaning is needed, especially in an era of privacy where people are very concerned about the data being used against it. I mean, you may even have individuals who deliberately put in wrong entries because they're trying to make sure the data can't be traced to them. For example, you may be doing a poll. A company might be doing a poll of its employees, and employees might be giving candid responses, and they may deliberately misstate, where they work, their job title, or various kinds of things, because they don't want that to be traced to them. And maybe there are assurances that the confidentiality will be protected, but people may or may not believe that. So again, there's a lot of work that is needed. What happens when a data element is missing? If the data element is missing, let's see, I think actually, let me go back, because I want to talk more on this side about data cleaning. One big issue that has been addressed very seriously in the statistical literature is what happens if a data element is missing. One simple choice is drop the entire record. So if a respondent doesn't fill out their entire survey, you just throw out the information. And clearly that's not very efficient because you're throwing away all this information. Another issue is you could just keep the fields on which they did report and potentially just omit the one field where they didn't have the data. A third approach is called imputation. That person didn't fill out their income. So what you do to make your record complete is you just put in the person's average income. Just put that in there on the record. A more sophisticated approach, because individuals who answered other questions in a certain way, bought certain cars, potentially have different incomes, is you could try to use a regression to develop a small forecasting model to try to predict what this individual's income might be based on how similar individuals responded to other questions. And so you could put in that kind of forecast there. That's better than simple imputation. The problem with that, of course, is that when you're putting in this number for the individual's income, you're putting in a guess. There's actually variability. And so if you just put in the real number, you are disguising the amount of variability associated with that record. There's actually more noise about it. And so the way in which you want to handle it rigorously is something called random imputation, where in effect you do the Monte Carlo, you create multiple copies of that record with all different possible responses in there, shaped according to the frequency of that response occurring. And then run the analysis all these different ways. Now that sounds horrendously impractical, but there are actually some well-developed methods for doing very much that kind of thing in a feasible way. In the literature on random and multiple imputation. So again, it's one of those areas where statistics has actually done a lot of work. It was interesting. I remember when I presented this problem to some people at Carnegie Mellon, and and the statistical theorists actually did a very, very nice job of coming up with very, very reasonable ways to address this issue. All right, identifying relationships in the data. One knowledge development is visualization. You may have all heard about Tufte. If not, T-U-F-T-E. You probably want to Google that. He's sort of the ancient guru of visualization. And there's a lot of different packages out there which talk about how you can visualize the results. The thing I think that's most important is to make sure you understand the logic behind what you're doing, because it can often help in making things visual. Think about what's going on. If you simply blindly take a visualization software and just feed your that into it, the visualization software will do its best. But if it looks chaotic to you because you haven't thought it through, then there's some chance it will look chaotic coming out. So again, try to do your homework in terms of thinking through, and doing as much thinking through it yourself. Visualization can help in that thinking. And so visualization can be part of your own thinking through and understanding what's in the data. But there's visualization you do for yourself and visualization you want to do for your client. Do your homework, do your thinking before you present it to the client. On the statistics portion, statistics is a huge and wonderful field. As Louise mentioned, I'm sort of a lover of statistics. I'm a bigger lover of operations research, but I love them both dearly. It's important. A lot of statistics won't be as essential. Make sure you have a better understanding, I think this is my advice, of descriptive statistics, exploratory data analysis, and regression. And you can Google those terms or whatever, but make sure you have a good heading on those kinds of topics, because those are a lot of the kinds of practical statistics that we want to use. When we talk about visualization, it's important to realize that clients have different cognitive styles. Some individuals are visual. Others are analytic. I mean, if we're presenting to analysts like ourselves, we potentially like the numbers. Maybe we don't necessarily like the visuals as much. Some individuals want to see details. Others want the big picture. Others want anecdotes. Some individuals want demonstrations. They want to basically see an illustration of what this implies. Or they want the ability to slice and dice data themselves. One of the things about data science, data analytics, is we're trying to build databases that can please a lot of different kinds of needs. It's important to remember that individuals have cognitive styles. There are people who genuinely want to get into and slice the data and dice the data themselves. And it's very, very important that we have the capabilities to respond and provide for those individuals. Other individuals want the big picture, want anecdotes, and so on. So again, we just have to be sensitive to the fact that different strokes for different folks. The other issue about analytics is there are some graphics which provide a nice illustration of the conclusions that the analyst believes the client should take away. And that's great if the client has a lot of trust in the analyst. And, clearly in some cases, for example, if you're consulting with one of the lead universities or one of the prestigious consulting firms, the client does have that kind of trust me kind of thing. But typically, you need to ask the question, is there a reason why they should trust you or your analysis? Like I mentioned, a person worked for me and her Excel spreadsheet got corrupted several times. I love her dearly. But again, I'm just sensitive to the fact that the Excel spreadsheet got corrupted. I'm just sensitive to the fact that any Excel spreadsheet that I haven't personally gone through is an Excel spreadsheet that might have an error in it. I've had my fair share where I've looked at people's graphical PowerPoint illustrations of a model, and then I look at the Excel spreadsheet that actually had the model, and I would run through and use Excel to backtrack different relationships, and I would find that that was no longer in agreement with the PowerPoint slide. The PowerPoint slide had been done at one point in time, but the Excel programmer continued to work and evolve, and somehow or another there was no longer alignment. So again, there's a few software packages, like there are some BaseNet kinds of packages out there, which couple the graphics with the data, so that if you change the data, the graphics automatically change, and so that the individual can see, if the individual asks, why this number, then that, it's very easy for them to pull that out of the analytics. And so it doesn't require a leap of faith. And again, as always, think hard about your visuals. The less blind faith that's required, the better. Because the issue about visuals is, a client will take the visual, and if it seems to display interesting information, it'll be passed on and copied by other people who are going to want to use the data off that visual out of different kinds of contexts. I mean, maybe you'll end up wanting to use the data off someone else's visual. So again, you want to be able to provide a white box as opposed to black box kind of information. Task 4, identifying relationships in the database. Filtering, filling and missing data with imputation, we've talked about that. Reducing the number of dimensions in the data. Dimension reduction is important, and in some cases it is extremely critical. In one of my past lives, was with a company that made many different kinds of products. And there was a fight between, some people who would say, we need to have fewer product lines, because that will cut cost, and because some of our competitors don't have many product lines. And others would say, no, our strength is having a wide variety of product lines that we can custom tailor to different individual needs. And that was the argument. What should we do and whatever. And so they came to, us and essentially said, if you take our customer base, how many different distinct kinds of customer needs are there out there? If customers were all pretty much identical, they all just wanted a product that worked and they didn't care about the color, they didn't care about this, and they wanted roughly the same kind of thing, then it wouldn't make sense to have, 20 different product lines producing 20 different mild variations, different variations of a product that the customer all viewed as the same. For example, in cars, there was a lot of attention at one point to something called orange peel, which is a little bumpiness to provide texture to the vehicle. And, there's a lot of interest about we need to have orange peel in our vehicles or whatever. We need to have this kind of differentiation. And so psychological studies were done that showed that that customers couldn't discriminate. There was a certain level of granularity at which customers couldn't even make out or see orange peel. And that was, facts that come to it. So likewise, segmentation was the issue that how much differentiation, how much discrimination is there out there? How many different kinds of buyers out there with respect to buying on our product? And if we had come up and said, well, there's only 2 or 3, that would pretty well have doomed those who said we had to have 10 product lines. So this was one of the cases where they were going to use optimization, decision analysis, various kinds of things to make the decision. But ultimately, the data, what the data ultimately said about how to segment the market into customers, that would have a profound effect about the answer. And again, a lot of political pressure on that. So that was an example where segmentation made an awful lot of difference to the final answer. So sometimes the data can speak for itself. Documenting and reporting results. You want to tie findings to the original analytics problem, tie findings to the business problem. You want to communicate the results clearly. You need to recognize that as an analyst, your perspective is contaminated. All the data, all these distinctions, all these terminologies have become so ingrained in your mind that it's hard for you, at least for me, I shouldn't speak for the rest of you, but it's hard for me to put myself in the shoes of someone who hasn't been soaked in the data as deeply as I do. And oftentimes you need to get the person's perspective. So that's part of the issue about communicating results clearly. It forces you to think deeply about what your results are saying and think about it, in the language of culture of someone who hasn't had the, in-depth exposure of wandering through and studying this data, as deeply as you have. Recommend change based on the results. Now here, there's a need to be careful. There's actually there's an old joke about certain consultants, not me, of course. And the joke was that if a company was centralized, they would recommend decentralization. If the company was decentralized, they'd recommend centralization. But no matter what the company was doing, they would recommend it would make a change, just so their client who had to pay their hefty bill wouldn't look foolish for, pulling them in. It's important that if there is no change, then of course you have to say that. Typically what you want to do is you want to look through the data and try to identify some insights, some learnings that will potentially lead to some changes. Maybe they won't be the big changes that your client wanted, but spend some time doing it. Don't try to be mechanical because again, you'll end up losing your credibility over time if people end up making these kind of jokes about you. at one point I learned it. Let me move on now to task 6. Using data analytics to refine the original problem. I just want to emphasize again that sometimes data refines the problem in a way that makes a really good solution obvious. In fact, this happened a fair amount in my experience. And at that point, the clients may end up saying, well, we don't necessarily need to apply modeling techniques. We can stop here because we already see from the data, but there's an obvious way in which we could make do something that's 3 times better than what we have now. Again, you can think about that. That did happen because clearly our purpose is not to try to compete with the modeler or undercut the modeler. We want to support the modeler. But a lot of times the data will come out with such a clean result that it will be pretty obvious how you can make the client can make a major improvement on where they are. And that did happen a fair amount of the time. All right. So how to prepare?
Excuse me,
running your
Bob?
Yes.
Could I interrupt for a second? Instead of going into these next slides, which are relatively self-explanatory, could you answer the question that's been posed by somebody? Could you explain prototyping again and refining problem statements as iterative, so forth?
All right, when you say will you just basically just frame the question again, please? Sorry.
The questions are, can you explain prototyping again?
Okay. Yeah, I didn't
and
think they went.
Okay, go ahead.
All
And
right.
they also asked if you would share your email address with them. You can do that if you like. Otherwise, they can send information to me, certification.org, and I will forward them on to you.
Okay. All right. So prototyping. I mean, it tends to. All right. So prototyping is when you take out a small example and just basically see what the data implies for that kind of example. So like when you prototype a vehicle or a car. It's something that clients typically ask for. They want to see it worked out with an example. They want to see it validated in a context where they think they know the right answer. I mean, if you end up getting unexpected results in a simple case, then that can help you, refine your plan for gathering data. If that's helpful in terms of prototyping, just working out in a small case, seeing whether it's giving you the results you want, and if not, then go back and revisit your data plan. And in terms of my email, I can probably, my work email is Bordley _Robert at bah.com. And that's Bordley, Robert.
And I think we might have time for one more question. Somebody has asked, is refining problem statements iterative?
Yes. Yes. I mean, absolutely yes. Everything is iterative. You do your best to try to use some kind of work breakdown structure so that the amount of iteration is as small as possible. By that I mean you try to break up the assignment of collecting data into different kinds of pieces. Like, one part might be collecting data on the engine, transmission, or different kinds of parts. So that if you discover, that you need to iterate on the engine piece or some other kind of component, then it's just going to affect, the engine data collection plan, not going to affect every other kind of plan. So you do try to use these I think the phrase is design structure matrix kind of methods, the basic clustering methods. You try to use methods so that the amount of iteration, which is a form of rework, is as minimal as possible. So you don't have a data collection plan that ends up being destroyed by complexity. But it's definitely iterative. But you want to do it in a sensible way to try to get your work done, because there's a lot of work you're going to need to do, and typically you have some very limited time frames in which to do the work.
Thank you, Bob. This gives us a lot of things to think about, and 'tis no wonder data is the largest area on the exams. There's a heck of a lot to consider when you're gathering and using data to find analytic answers to problems. Thank you very much, and we'll end this broadcast and see you again in 2 weeks when we will be discussing the methodology selection.